Hi, it's Tian, and my project is about load disaggregation and demand response. Load disaggregation and demand response are concepts in smart grid. So right now, the utility price right now is constant, and we love to develop a mechanism that we use a dynamically change the utility price so that the user could adjust their power consumption according to the utility price, and then the power company could adjust the utility price to reduce their peak load. Load disaggregation is by reading one whole power consumption in your home, we could find out which devices in your home is on and which is are off. So we could forecast the power consumption for your home in the next hour or the next 3 hours, and then we could feed this information back to the utility company, and the utility company could adjust the utility price according to the information, all the information they get from all the users. So then the utility price will be determined by the information they get, and then the utility company could reduce their peak load. So while our main goal of the demand response is maximize the social welfare.
Yeah, we did like a Crayfish Receptor Stimulator for the bio lab. Yeah, you can see this is the whole setup for the Crayfish Receptor bio laboratory, and so we set up the Crayfish to like a. And what we did is this part to control the drag to the crayfish tail. And for the bio part, they have the equipment such as like an oscilloscope and connectors to detect the nerve, like how the nerve reacts with the drag. So before they just use a manually like a drag to control the crayfish tail, but it's a kind of it's not like a very precise, and also we need like a more constant distance and speed control receptor and simulator. So this is our like the high level design. So basically we are using a microcontroller to get the user input from the knobs and push buttons, and send out a PWM to control the servo motor, which can turn a certain angle, which will drag the crayfish tail. So we did in the software part. We designed a state machine inside the microcontroller. We're using the tape to like just simulate the crayfish tail. In the lab, we're gonna use the real one. So that's a servo motor. This is the user interface. And when we press initial set, it's just setting initial position. You see, we can turn this one to set the initial anywhere you want. Usually we set it 0. And after we press the final state, which is setting the final position, it gets into another state, which reading these knobs. Like let's say we set the final position here, and this initial position set push button also reacts as a reset. When we push it, it will just reset to initial. And so after you're setting this part, you can just hit this start. It will go from the initial to final. And if you want to do one more step, you can just simply press this button. And also you can change the speed whenever you want. So what we see is like a kind of slow. Let's say we increase the speed to 5, and this one is definitely faster than the one, which is, you can see this is so that's the whole thing, and generate the waveform. You can see like at that point we start the drag, and the crayfish tail nerve reacts very like it's a very high frequency wave at the first instant, and it adapts itself to like a pretty, it slows down a little bit to like a constant waveform, which is the result waveform of our project.